My name is Meng Lu.
My name is Noriko Yasui.
My name is Francisco Rodriguez.
We're all from Wolfram. Our talk is translating Wolfram Alpha into more languages. It's about localization of Wolfram Alpha, the computational knowledge engine. So just a little bit introduction to Wolfram Alpha itself. Wolfram Alpha is Wolfram's unique system for computing answers and providing knowledge. And we call that computational knowledge engine. Okay, yes. You talk. And the primary product form is the public website, wolframalpha.com. It's released in 2009, about a decade ago. And it has become one of the most popular Wolfram products. The goal of Wolfram Alpha is making the world's knowledge computable. Just some words about computational knowledge engine. It can be logically separated into 4 parts or layers. The natural language interface is, that allows questions and queries to be given in natural language, but so far only in English. And we have the foundation of systematic curated data that has trillions of pieces of data in over 1,000 different knowledge domains. We have different types of data, but the textual data is almost always in English. And also sometimes the data source we use for constructing the knowledge base is English language only and the US primary. For example, the flights, if you were to ask flights over some city in other countries, it'll just say data not available. Computational intelligence, that's essentially the domain expertise that's built into the system as automated methods for solving problems and deriving information from data. And at the end, at the top level, we have a dynamic presentation of the knowledge it computes. So that includes the formatting of results, summaries, and visualizations. That, of course, it's all in English. And also the design could be English language or US-oriented. That said, at the real implementation or code level, all the 4 components can be mixed. So that leads us to the localization of Wolfram Alpha. So on one side, Wolfram Alpha has an ever-expanding coverage of knowledge domains and increasing ability to answer questions. There's a totally different dimension to grow this, is we should extend the natural language interface and the presentation of knowledge into other languages, and also broaden the user base and the content coverage into other languages and regions. So if the goal of Wolfram Alpha is making the world's knowledge computable, the localized Wolfram Alpha is to make this operation more accessible internationally. Our 1.0 release goal is to make all the math-related features localized into 6 different languages: Japanese, Spanish, Chinese, Korean, French, and Russian. Here is to show you some example outputs. I think I will let Francisco.
Hi. Yes. So here we have some outputs on how this will eventually look in the web. So right now this is still under development. We have the internal pages for these development pages. And in general, as you can see, we are trying to translate everything that is text into the language. And not only the text, but also some conventions. For example, as you can see, in Spanish, in French, and in other languages, we use as decimal separator the comma instead of the point. So we should also change that in the output. In the graphics, you might see that. And so every piece of text should be localized in the right language. here is an example of all the, we already have all these languages working somehow in not all the domains, because this is a project ongoing, but we have many examples that we can show. So in general, this project requires many steps that we are going to explain.
Yeah, so we will spend the next few slides trying to explain why localization is important. So if you look at how many languages are there in the whole world, there are over 7,000, but only 25 has more than 50 million speaker population. And 15 million is about 0.6% of the world's population. So only these 25. And it's visualized in this plot. So all the rest of the languages is in this small corner. And here are the largest ones. And we're currently working on the following 6 languages, adding the existing English. That's the highlighted part. And that's approximately, excluding English, it's approximately 1/3 of the world's population.
Yes, and if we think about the geographical coverage of Wolfram Alpha, right now, with English, we are covering this area. But with the new languages, we are going to cover a lot more. So we are going to have presence in all the continents with these 6 new languages. With everything together, we might cover most of the world, geographically speaking. So this is a good motivation to start this project, of course. Most of America, a lot of Africa, and well, Europe is very diverse, so we are starting that. Yes.
So this is a time series chart for false refraction and now what's that? Average query length, and then query fraction with non-ASCII characters. The first one is false refraction rate. False refraction means percentage of queries not answered. So as you can see, the 2 to 3 months after the release, we have not really good false rate, but it's Wolfram Alpha is updating weekly, so it's getting better and better and better. And then recently, we have just more like 5% false rate. And then the average query length, we got like 15 to 12 lengths. Query, we got the first around release time, and then it's getting longer and longer, and then recently we get more complicated, longer query we get. And then the last one is a query fraction with non-ASCII characters. It's a weekly average, but so it's getting increasing the number of non-ASCII characters.
These non-ASCII characters are just a view of how many people is trying to write something in non-English. Mm. So still there is like a 5% of people that is writing things that is not in English. So that's why we should try to answer them. And also another view of why we need this is, for example, this is the traffic that we get by browser language. When you have properly set up your computer, you usually put, I speak Spanish, I have my Firefox in Spanish, I have my navigator in German, in Russian, etc. And this is what we get from the stats. So the second language that has more hits in Wolfram Alpha right now is, for example, Spanish. I have here in bold the ones that we have chosen for now. So still we have 70% of English speakers that is trying to use Alpha, but we want to increase these other numbers. So that's part of this motivation to start this project.
Okay. So then we will spend a few more slides on the development, actual development. So some basic facts first. The team consists of translators, data curators, developers, testers, that many of which are language natives. And overall, there are dozens of people that's involved to different degrees. So localized Wolfram Alpha is built on top of the regular English language Wolfram Alpha. And that's the features is inherited into the localized build. So the localization happens to the selected components gradually with the original behavior as fallback. On the input side, you can still ask those queries in English. Then the rest of the features, basically the rest of the features you can still query normally in English. And if it's localized, you can query them in both English and the localization language. On the output side, it's the same. Until it's fully localized, it can show up as a mixture of localized plus English. So the next is the different components that we work on for localization. The largest component in terms of the actual new data points or lines of code that get created is the curated data. And there are two places where this happens. One is there's a huge set of source files. So these are just nested lists of basically key and value pairs. These get translated and stored back into the files. And the other big part is in the relational database, which got translated and it's merged with the existing data. Besides data, there is also a lot of work to do with the source code itself. So one big part of that is grammar rule. So there is a grammar rule symbol in the language itself, and we have something similar in the Wolfram Alpha system. Also, on the output side, there are a lot of code that constructs results, summaries, visualizations, many of which requires refactoring. So one big part of doing this is trying to extract these text that's for display, but it's all mixed in some computational logic that's doing some language independent things. But it's all mixed, so the first step is to extract them. Then we store them in a separate database along with these curated translations. So this is just some small part of that. The actual translation, so we will do some machine translation first, but we found that has some limited use only because the fraction of poor translation is really high. Many of these has to do with some proper nouns or some technical terms. It's not translated in the correct context. It's often too literal. In some cases, we use machine translations as the first draft before manual curation and proofreading. We also use data sources like Wikipedia and Wikidata to translate the named entities like chemical elements, cities. For example, 20% of all the city names can be translated this way into Japanese. There are also some other miscellaneous tasks that's related to translation. For example, in Chinese, there is, because the words in Chinese, they are not separated by white space. So we can do something to separate this, then turn them into linguistics patterns that's used for understanding the queries. This is one example. So we use mathematical notebooks to carry out the actual translation and data curation. So this is one example of such notebook. This happens to be one for translating units. We have the original English name, the translated name, and these are the patterns or alternative names for these units, and also some reference links to external sites. Okay. So that's the regular workflow, but we also encountered some challenges. So this is the most obvious one is that we have a huge amount of data and the source files or code to localize. We have about approaching 10,000 relational database tables and over 1 million names and descriptions of entities and properties, units. And on the input, on the parsing side, we have linguistic patterns. So the smallest unit is what we call token. What we call token, basically they are the semantic constituents in the query that all have to have some patterns to match with. So that's 10 to the 7th. We also have a higher level thing called grammar rules. That's approaching 10 to the 4th. For source code, we have 10 to the 5 source files, 10 to the 7th lines of source code. All of these can have this mixture of data and logic. So that's really a lot of data and code to look at. On the other side, these data are they're heterogeneous in the way that they're scattered all over in files and in databases. And also it's mixed. Data and the logic for doing computing, it's mixed. When you have so much data, you naturally want to divide and conquer, but there are many different ways to do this. Sometimes you want to divide it by the content domains, sometimes by the user visible features. The two are not the same. They are like the domain and range of some function that they cross over. So another important thing to realize is that Wolfram Alpha's outputs, they are not static, they are all dynamically generated. So as a consequence of that, first, the source code themselves requires localization. And until you have everything localized, you may not really realize the output is broken. You have some partially down localization, then the output will show you that you need to do more. Also, yeah, I think I'm going to skip all the details. Right. So, yeah. So as you know, the consequence of all of this is that it's hard to measure the overall completeness because Wolfram Alpha is always growing. So it's almost impossible to say it's all done. Okay. So one big part of our work is to do the refactoring of the code, and our code base is almost a decade old, so there are a lot of legacy code. So localization partly takes care of housekeeping. The original implementation are often mixture of data, computation, styling. They are not logically separated. So, we just review these code, trying to separate these. Two examples. One is, ordinal form. We used to have this function that turns integer into these ordinal numbers, and it turns out there are many, many different implementations and inconsistent usage. So 10 lines of original code turns into 150. in order to support 6 more languages. Another thing that's used very frequently is we turn the original, perhaps it's just joining parts together. We turn that into a template, so this template itself can be translated into different languages. These variables will be evaluated when the system is running. So also Wolfram Alpha is released weekly, so the content data and source code, they get hundreds of changes daily. So it's very hard to keep everything consistent. Yeah.
And yep. So also we had many language issues, and that's part of the work we had to do. So for example, we had issues with grammar conventions of each language, also with writing scripts. So the characters, for example, in the Wolfram language are only supported up to plain 0, and in some languages we have the need now of using more than plain 0, for example, for the element names in Chinese. Also, there are things that we have added in the language itself because it was needed for Alpha. For example, the extended support for functions like to lowercase, etc., that was not properly done before, for example, for Cyrillic. And all this has been incorporated also into Wolfram language. Also, another challenge we had is the usage of the files, because the files are encoded in Mathematica encoding, and it's not very nice to look at them in other, let's say, more common developer tools, like even Wolfram Workbench doesn't display properly the special character from Wolfram language. So this is what we will see in one case, and in the Mathematica front end, we can see the proper characters. But we need to handle both, because we have tools also for doing, for example, the diff of the files, etc. And there are some tools that has been made in Wolfram language to handle that. But anyway, it's hard to mix all this. And about the status, we are planning that the first release will be initially of Japanese and Spanish. Only the math-related stuff. Right now, the overall progress is around 51%, but counting for all the languages. Of course, Japanese and Spanish are a bit more advanced than other languages. But we are already working in Chinese, French, Korean, and Russian, so all this is coming. And well, we want to thank the team of localization. We have a huge team. We cannot put all the names there, but this is a picture we took taking a few days ago, taking the opportunity that many of us which work remote are in town. So, well, that's it for now. I don't know if you have any questions.